circle. Here's the equation of the circle. X minus h squared plus y minus k squared equals r squared. Where h is the x value of the center, k is the y value of the center, and r is the radius of the circle. If you're not given this equation, you have to memorize it, but if you did pretty well with point form, it's kind of that same concept. Okay, just looks a little bit different. Once you get the pattern down, it's not so bad. This next section, we're going to talk about how they derive the equation of a circle, where this equation came from. I'm never going to ask you to repeat this on a test. It's just good to know. Good to know where something comes from in math, if you'll understand it a little bit better. So if you find it overwhelming, just kind of, okay, that was a lot, and just forget about it. Okay? But it is something we do need to go over. So just, I know it's maybe a little confusing, but just hang in there. Okay? We can use the Pythagorean theorem to show how to derive the equation of a circle given its center and a radius. So HK, the point HK, is the center, and XY is a point on the edge of the circle. And let's say, hey, we want to find the distance of the radius. When we're finding distance in the coordinate plane, we make a right triangle. And we use the Pythagorean theorem to find it. So we need to figure out, well, what's my A, what's my B, and what's my C? Well, which one has to be our C? Which one's across from our right angle? R, right? R is our C. That one was easy. Then it doesn't matter. For the sake of the equation, though, I'm going to make this bottom part my A, and the side part, the up and down part, my B. So it matches with the formula. The problem is, we don't know any numbers. They didn't give us what we're counting by. They didn't give us specific points. They just gave us variables. We can still figure out an expression that represents the distance. Because at this purple point here, we're going, A starts at this purple point, and it ends at this green point. So it's going from the purple to the green, right? And we're going horizontal when we count. Well, if we're going horizontal when we're counting, are we going by x's or by y's? We're going horizontal. X's, right? We're counting the lines on the x-axis when we go horizontal. Well, look at the x values of those points. What variable is representing the x value of the purple point? What's the x value of that point? What's the x value of the center? H, right? So H is representing the number at the purple point. We don't know what it is. It's being represented with H. And then if we go to the green point, there's not really coordinates of the green point, but it's in line with that orange point on the circle. So they share the same x. They're in line. They share the same x. So what variable is representing x in that orange point on the circle? Look, what's representing the x value? X, right? So it's going to have the same x value at that green point. So that green point is also going to have whatever x is. We're going to write x. And when we find distance, what do we do with the values? We're finding the distance in between 2 points, the distance in between two numbers. What do you do with those numbers? You subtract them, right? Okay. So when we subtract, do we do little minus big or big minus little? When we find distance. You do big minus little, right? You do the furthest distance minus the closest distance. So we're going to do x minus h. And that's representing our x. Whatever x is minus whatever h is, that will give us the distance of that side. We just don't know what those are. We have to use variables. So now we're going to do the same kind of concept with our b. Okay? I'm going to label this one blue and keep that bottom one green. So, we look at the top point, that's probably the easiest. Now we're going up and down. And what values do we look at when we're counting up and down? Look at the y values or the x values? Y, right? Because the y-axis is going up and down. So we count, we're counting the y values. So if we look at that top blue point, which variable is representing the y value of that point? Y, right? If we go to the bottom, the green point, it's in line with this purple point. And what variable is representing the y value of the purple point? K, right? So the y value of the purple point is K. The y value of the green point is also going to be K because they're in line with each other. And again, what do we do when we find distance? Do we add or subtract? Subtract. And we subtract big minus little. Well, which one's bigger? The K or the Y? Higher up. So it's going to be Y. So when we find the distance of this side, we're going to do Y minus K. Now we know what an expression for our A is. Now we know the expression for our B. So now we can plug those into the Pythagorean theorem. And our A was x minus h. So it's a squared. Plus our B is y minus k squared. And our r, when we plug it in for C, is r squared. And that's where the equation of a circle comes from. That's why it is greater than this. Using that logic. I know. Yeah, I'm not going to ask you to have to explain it on a test or anything. It's just good to know where it comes from. Something that they're like, hey, explain this to them. So I do. Yes. For the blue point, the y is higher up. So as further from the axis you go, the higher you go, the bigger the number is going to be. So because this one's higher up, it's going to be bigger than the green one. Here's the equation. So what you need to know that equation. You don't really need to know where it comes from. You don't have to. Right? How this is going to work. One thing I want you to notice is if we go back here to the center, the point is HK. What happens to the H when we plug it in? It's positive written in the point, but when we plug it in, it turns what? Negative. What happens to the K? It's positive, but when we plug it in, it turns negative. So a shortcut to maybe remember is that when we plug the point into the equation, the signs change to the opposite. If the point's positive, when you plug it in, it turns negative. If it's negative, when you plug it in, it turns positive. So we'll do a long-handed one and then a short-handed one using that shortcut. So take a look at example 1. It says, what is the standard equation of a circle with its center is at 14, negative 1, and the radius is 12? Well, we're writing an equation of a circle. So I'm going to write down kind of that generic form. And then plug it in. How the pattern for plugging it in. The x and the y stay x and y. That doesn't change. So it's going to be x minus something squared plus y minus something squared equals something squared. You just have to use the equation to figure out what's going to be planned. So what's going to go inside with the x is the x value of your center. What is the x value of our center? 14. Then what's going to go in with the y is the y value of your center. What's the y value of your center? And then what's going to go here is r. What's our r? And then you clean things up. Can't really do anything here. That's just going to say x minus 14 squared. Plus, we have a double negative, so what's it going to turn? Positive. So that becomes y plus 1 squared equals, what is 12 squared? 140. There's that equation. Biggest thing I see is we forget to put the squares, and then we forget to actually square the radius. That's a big thing. We'll just leave it as 12 squared. We won't actually square the radius. You have to actually square it. Right? And you have to put the exponents. We forget to put our exponents there, and you have to remember to put them. Okay? Questions over that? equation of a circle with center -7, 5, and the diameter is 18. Sorry, before we go into that one. Again, notice that pattern. So 14 was positive. When we plugged it in, it turned negative. So 1 was negative. When we plugged it in, it turned positive. So you can just do that right away. If you want to do this middle purple step, go for it. Or you can dive right into the answer. Okay? I don't care which way you use. So kind of a shortcut way is they gave us our center and they gave us the diameter. But what do we have to plug into our equation? The radius, right? What do we do with the diameter to get the radius? Divide by 2. What is 18 divided by 2? Well, our radius is actually 9. Make sure you pay attention to that wording. You only do that when it says diameter. Okay? But we want to write an equation. Fill out my skeletons. My equation. The x value of your center goes in with the x, but what happens to the sign? Changes. So what's the x value of your center? -7. So when we plug it in, it's going to turn to a +7. What's the y value of my center? 5. When we plug it in, it's going to turn negative because it's positive. And then what do we have to do with the radius? Square it. What's 9 squared? 1. So they gave us the diameter. So what we're plugging into our equation has to be the radius. So we know the radius is half of the diameter. So we just cut it in half. We divide by 2. And that gives you the radius. Sometimes you're given the radius, sometimes you're given the diameter, so just make sure you read the wording. You don't always have to divide by 2. You'll see that when you're given it. Questions over there? For the next one, we're going to go backwards. We're going to be given the equation, and then we want to state the center and the radius. So our center is whatever's paired with the x is the x value of center. But what happens to the sign? It changes. So there's a -9. When we take it out, it's going to become +9. When you plug it in, it changes. When you take it out, it changes back. Whatever's paired with a y, so y value of your center, but it's a +2. So when we take it out, it's going to become a -2. And then we have our radius. It's r squared in the equation. So we have to do the opposite when we take it out. What's the opposite of squared? Square root. And the square root 49. What is the square root of 49? So there's our radius. Here's our center. I is saying, does the point 15, -5 lie on the circle? Well, algebraically to show that, what you can do is you take the point and you plug it in for x and y. Tomorrow, I'm going to show you how you can use Desmos to answer this question, which is much easier, but it's good to know the algebraic way too. Okay? Just in case you don't have Desmos on hand, you can still answer the question. Okay? So we're going to take 15 and plug it in for x. So it becomes 15 minus 9 squared plus, we're going to take the -5 and plug it in for y. And get 49. Simplify it down. What's 15 minus 9? What's -5 plus 2? And then you can go ahead and just plug that in. Make sure you put parentheses around the -3 when you square it. If you don't, the calculator does not read it correctly. You're going to get the wrong answer. Okay? It doesn't make it positive when you don't put parentheses around it. When you square a negative, it turns positive. So what do we get when we do 6 squared plus -3 squared? What is it? 45, right? Is 45 equal to 49? No, they do not equal each other. So does this point lie on this circle? The answer is no. It actually lies inside the circle because what we got was less than 49. So it lies inside the circle. If we got bigger than 49, then it lies outside the circle. But I just want to know if it lied on the circle and the answer is no. Okay. So the question's over there. If we take a look at example 4, determine if the center and the radius of the circle. So for our center, negative 8 is paired with the x, so when we take it out, it turns what? It turns positive. Here's the thing with the y. Are we adding or subtracting anything with the y? No. So what do you think is paired with it? 0. We're not adding or subtracting anything. We're adding or subtracting nothing. And 0 represents nothing. So whenever it's just x squared or y squared, it's just 0. And then what do we have to do with 100 to get our r? Square root it. What's the square root of 100? There you go. There's your center and your radius. And then I says, does the point 3 radical 75 lie on this circle? We're going to do the same thing we did last time. We're going to find out algebraically. We're going to take 3 radical 75 and plug it in. So 3 is going to go in for x. And radical 75 is going to go in for y. And then we simplify it down. What's 3 minus 8? 3 minus 8 is negative 5. Plus, when we square a square root, when we square the square root of 75, what do we get? The square root of 75 is a decimal. What do we get? You get 75. Because when you square a square root, they're opposites. So they cancel each other out. The 2 goes away, the radical goes away, we're just left with 75. What's negative 5 squared? 25. What's 25 plus 75? 100. So we get 100 equals 100. Are they equal? Yeah, so does this lie on the circle? Yeah. So when they are equal to each other, when you plug the point in and you get the same thing, get 100 equals 100. It does lie on the circle. If you don't get 100, then it doesn't lie on the circle. If it doesn't end up equaling the radius, then the answer is yes. If it does equal the radius, then the answer is yes. Questions over there? We can graph. In order to graph, you have to know 2 things. You have to know the center, and you have to know the radius. The center is telling you where the circle is starting at, and the radius tells you how wide the circle is. So you have to know those 2 things in order to graph a circle. So just like we did in those previous 2 examples, what is our center looking at the equation? 2, negative 4. Good. Signs change. If it's negative, it turns positive. If it's positive, it turns negative. What do we have to do with 36 to get the radius? And when we do that, what's the square root of 36? Now that we know the center, now that we know the radius, we can graph. You plot the center. So we're going to go to 2, negative 4. That's where the center of that circle is. going to count the radius in 4 directions. Up, down, left, right. So we start at the center, and we're going to go up 1, 2, 3, 4, 5, 6. Put a point. Go back to the center, go down 1, 2, 3, 4, 5, 6. Put a point. Go back to the center, go right 1, 2, 3, 4, 5, 6. Go back, and then go left 1, 2, 3, 4, 5, 6. You then connect those points in a nice circular shape as best as you can. I'm probably going to look like a potato. The smartboard's a little off, and I'm not the best artist. But don't make it look like a square. That's actually pretty good for me. My other one was way off for scary. So they have to be rounded. If it looks like a square, if you're going like this, no, I'm not going to do that. Or not. That's a square. Nice rounded. You're all in a circle, make it look like a circle. The best you can. I know it's hard. But make it round though. Make that a little bit more rounded. No points. We don't want corners. Circles don't have corners. Try to make them as rounded as you possibly can. Watch. Sometimes I like to do, I'll start, kind of do half, I go, and then do half. That kind of helps. We're hard at guessing where the circles are. But just do your best. We're not looking for models. Questions over that? And then the last example, we can have the graph, and then we write the equation. So in order to write the equation of a circle, you need to know the center and the radius. You're going to get that from the graph. A lot of the times, the center is indicated for us for a nice dot. Right? Where is that point located? Yeah. So our center, they gave it to us right here at -5, 6. To get the radius, you're going to start at the center and just count outwards. So I'm going to start here. I'm going to count out till I get to my edge. How far did I count? What's the length of our radius? We start at the center. It's 5, right? So our radius is 5. Then we write the equation just like we did on the front. The x out value of my center is -5. When we plug it in, it's going to turn what? My y value of my center is 6, but when we plug it in, it's going to turn. And then what do we have to do with our radius? What's 5 squared? 25. If we take a look at B, our very last example, what's the problem? There is a center, they just weren't nice and they didn't give it to us. Right? But we can find it. What we have to find first is the radius. Right? How do you think we can find the radius? We don't know what the center is. What do you think we can do? Yeah, very good. Very, very good. We count all the way across, which is what we call the what? The diameter. What do we know about the radius? Is what is the diameter? Half of it. So you count all the way across, as the CC said. Right down the middle, all the way across. 1 and 8.
Okay.
What do we get when we count all the way across? 6. So that's the diameter. The radius is half of that. What's half of 6? 3. So this is 6. Cut it in half. And that gives us our radius 3. Now that we know what our radius is, we can find our center. You're just going to start at the edge and count your radius. And where you land, that's where your center is. What are the coordinates of your center? Now you can write the equation. The x value of your center is positive, so we plug it in, it's going to turn negative. Same thing with our y value, it's positive, so it turns negative. And again, finally what we have to do with our radius, square it to get 3 squared is 9. And there's your equation. Questions over that? Okay. Tomorrow,